Okay, so today we're talking about quadratic formula and the discriminant and what the discriminant can tell us and where do we get that. So if you remember, the quadratic formula from yesterday is x equals negative b plus or minus the square root b squared minus 4ac all over 2a. Well, the discriminant is this underneath the square root. Okay, this discriminant tells us how many solutions a quadratic formula has. So how many times does it cross the x-axis and so on. So the discriminant is under the radical, and that means square root as well. So if under that square root is a positive number, then I'm going to have two real solutions. If under the square root is a negative number, then I'm going to have 0 real solutions and 2 imaginary. And we learned what imaginary was. And if under the square root is 0, so if it just equals 0, then I'm going to have 1 real solution. So we're going to talk about what all of those mean throughout this foldable. So on the front of this, I'm just going to put what the discriminant equals b squared minus 4ac. So that's what you're using to determine how many solutions and so forth there are. So first let's look at if the discriminant is equal to 0. Okay, so here we're going to look at, we're going to find the discriminant. So b squared minus 4ac. Well, that's negative 10 squared minus 4 times 1 times 25. This becomes 100 minus 100, which gives me 0. So if we look back on if it's 0, what does that mean? It means that there's only one solution. So if we look at that graph, well, let's figure out what the solution is first. So the solution on this we can actually factor because there's numbers that multiply to be 25 but add to be negative 10. So negative 5 and negative 5. And remember, if we set those equal to 0, I get positive 5. So and they're the same, so that's only once. So if I go to 5, put my parabola, it's positive, so it's going to open up. That means it touches the x-axis there one time, but it doesn't cross and go all the way through and have two solutions. So here's your one solution, just right there where it touches. Alright, let's look at this example. So my discriminant would be b squared minus 4ac again. So 2 squared minus 4 times 1 times 5. So that's 4 minus 20, which is negative 16. Okay, well that's negative, so that's less than 0. So in order to find this solution, let's see, can we factor it? 1 times 5. There's nothing that multiplies to be 5 that adds to be 2, so that means I need to do quadratic equation. So negative b plus or minus the square root. I know that's negative 16 because I already found it. All over 2 times 1, which is just 2. Okay, if you remember, the negative comes I, square root of 16 is 4. So this is negative 2 plus or minus 4i over 2. If I reduce both of those, negative 2 over 2 is negative 1. 4 divided by 2 is 2i. Okay, so that's my solution, is this complex number. Okay, what this means is that there's two imaginary solutions, which there's no real solutions. So this means that your graph should not cross the x-axis. So if I go ahead and graph it, and let's look at that. We have x squared plus 2x plus 5. Okay, let me change that window back to normal. It looks something like this where it crosses at 5 and it's up above the axis. Okay, so our solutions tell us where it crosses the x-axis. Well, this one doesn't. That's why there's two imaginary solutions and no real solutions. So there's our graph of that. So on here, this is if your discriminant is less than 0. So your discriminant is negative, and I forgot the R. Okay, let's look at this one. So again, b squared minus 4ac, I have 1 squared minus 4 times 6 times negative 15, which is 1 plus 360, which is 361. Okay, that's positive, so that's greater than 0. So, again, if we take the here and try to factor, this one might be easier because that would give me a large number. Let's see what it gives me. It would give me 90. So yeah, I could do that. Negative 90, 10 and 9. The 9 needs to be negative because it is a positive 1 that it needs to add to. Divide by a. I can reduce. To 5/3 and negative 3/2. So my factors are 3x plus 5 and 2x minus 3 equals 0. So when I set them both equal to 0, this one gives me x equals negative 5/3, and this one gives me x equals 3/2. Alright, so what this means is that there's going to be two solutions. Crosses the x-axis twice. So if I go ahead and graph that, so that's what? Something like that. Okay, so this is where the discriminant is positive. So on the outside, we should be writing that the discriminant is greater than 0 because it's positive. And I can't spell today. Sorry. Okay, so that's that. Your assignment for this, I'm going to write on the back of it, is A17, page 297, 22 through 38 evens. And on 22 through 30, you have to solve. So give me the solution. So that would be like the solution box. And then 32 through 38, give me the number of solutions. So use your discriminant and tell me how many solutions there will be. Alright, please let me know if you have any questions, and good luck.